to IIT of Andhra Pradesh. Okay, so I was telling your director that it's nice and it will be historic for him to say in future that I started IIT in Andhra Pradesh. Okay, so that is a very good thing, and I also find quite good the team here, and of course my team was the people who built ISRO with the bricks and mortar, and if they are here, I'm sure your institute also will have very good strength. And your professor Raghuram Raj and your director Sachinayana, in a very short time I found them quite enthusiastic and quite passionate about your institute. All the best for you. Now, I'm going to talk to you about reaching out to Mars. Basically, not just about the ISRO's mission. The ISRO's mission is very, very small. You will come to know that. This is about all global missions. So, going to Mars is started right from 60s, not now. Right from 60s it started. If you want to go to Mars from here, it is not like putting a satellite in Earth's orbit like almost every once in a month we do now. Or in the world, 80 launches take place every year, 80 to 90. Going to Mars is very difficult for two reasons. It is something like you have to jump from a rolling and rotating ball and reach another ball which is rolling and rotating. This is the difficulty. As you know, you must be thinking that you are all sitting quiet, but you are not sitting quiet. You are rotating at a speed of 1800 kilometers per hour and also moving around Sun at 1,06,000, roughly 1,06,000 kilometers per hour. We are not feeling it because the space is not having variations as we see on the roads here. If we travel at 60 kilometers an hour, you will be worried whether you will hit somebody. But we are now moving at this speed, 1800 kilometers an hour we are rolling, and 1,06,000 kilometers an hour we are traveling around the sun. And Mars also is doing almost like that. It's rotating almost at the same speed like us, and it's of course a little bit slower around the sun. So we have to jump and go there. So now we will see. Now, as you know, because just to show you, we have inner planets and outer planets. So the Mercury, Venus, Earth and Mars are called inner planets, and we are about 150 million kilometers from Sun. And Mars is about 225 million kilometers from Sun. We call it 1.5 times the distance. Distance from Sun to Earth is taken as one unit, and the other one is called 1.5 times the distance. So these are the things. And of course, the other planets you know are there: Jupiter, Saturn, Uranus, Neptune. Pluto was, when we studied, it was called a planet of the solar system, but it is removed recently, and it was called. There are a set of stones. We call it, okay, some stones are as big as our hills. They are a set of asteroids which are moving around, which is that's why any mission beyond Mars is much more difficult. There were some missions, and we were hours together watching whether anyone will be hit by the rocks there. Luckily, nothing happened and it went through. And the reaching to Mars is very important because Mars, at least surface, is as much like on Earth. So all the understanding of the scientists is, if we can find out from the Mars what happened 4 billion years ago to that planet, we will find out what will happen to Earth in the future. That is number one. And if at all there is any place in the solar system in the future for the humans to live, the Mars is identified as one possible place. So there are a number of missions which have taken place at this. Now, if you take the details of the Mars, its average diameter is about roughly half of the Earth, 6,780 kilometers. And distance from Sun, as I told you, is about 227 billion kilometers. And it revolves around the Sun 1,687 Earth days. That means roughly 2 years, 1.88 years to be precise. And the day, on the earth we call it day, and on the Mars we call it soul. The name also is given by earth people of it. We call it soul. Okay? That there is a rotation period almost like us. So the day and night are like on here. It is the only thing is slightly different, about 30 minutes more. We are one period of rotation of the earth is 23 hours 56 minutes, whereas for the Mars it is 24 hours 37 minutes. That's about 40 minutes fast, 40 minutes slower. Okay. That average surface temperature is minus 53 degrees, average, and it can go in daytime as much as minus 120 degrees centigrade. And it has two modes called phobos and deimos. Now, it has got one big difference is it has got 95% carbon dioxide in its atmosphere. And as you know, most of the Earth's atmosphere is nitrogen and oxygen, whereas it is 95% carbon dioxide on the Mars and very low atmospheric pressure, and daily temperatures vary, and there are dust storms across the whole planet. It's not just small place. From one end of the planet to the other end of the planet, there will be dust storms. Means the dust which will be lifted and which will be landing is estimated to be much more than the hills what you see and mountains what you see on the earth. And volcanic activity there. Mostly it is considered that the solar winds were responsible 4 billion years ago for the Mars to lose all its atmosphere. Now, what happens? How do you travel between Earth to Mars? Okay, this is called transfer orbit. This actually from anywhere to anywhere if you go, if you want with the least energy, by spending the least energy, it's called Hoffman transfer. But Hoffman transfer is not simply possible here for reasons I tell you. But as I told you, the Earth also will be moving around. This is Sun, this spot. Earth will be moving in this circle, and the Mars will be moving around this circle. So if you want to go from Earth to Mars, Mars will be somewhere. It will also be traveling. So we should plan in such a way that our satellite reaches the place, and exactly at the same time, Mars also reaches this place. Then only it is possible to catch it. It should be, calculation should be precise to at least a few tenths of seconds. Otherwise, it's not possible. Otherwise, there were missions which just escaped Mars and gone. And there are missions which of course could not take off at all because of other problems. Now, you can only travel exactly with the least energy. If you have good energy, no problem. With least energy, if you want to reach, the first configuration should be called opposition configuration. If the Earth is there, Sun and Mars should be on two sides. Sun should be on one side, Mars should be on the other side. That is the first requirement. Second requirement is, it should be at an angle of 44.3 degrees in this path. So if it is at 44.3 degrees, it will take roughly 259 days from here to reach here, and the satellite which we leave here, which leaves Earth here, also takes 259 days, so that exactly after 259 days both of them reach. Okay? I find a lot of young people, students, it is something like, Hindi cinemas, our time Hindi cinemas, the heroine used to go in the train, and on a covered road, hero comes in a jeep, and they start looking at each other and smiling and all the things. Somewhere they will be. It is something like that. The train is moving and the jeep also is coming. Both should reach at one point. Okay, it's exactly like that. Okay, I think Right. Now, this happens, this computation, because as I told you, Mars takes roughly 1.88 years to complete one revolution, and Earth completes 1 year to complete one revolution around Sun. So this particular combination happens only once in 2.13 years. That is 2 months. Once in 2 years. One opportunity if you miss, you have to wait for 2 years, 2 months. And now assume in future, if the people go there and live on the Mars, to travel there, they will take 10 months time. And then they have to wait there 2 years exactly to come back. And then by coming back, they will take another 10 months. So with today's technology, today's chemical propulsion technology, if we happen to reach very safe nuclear propulsion later, things will be different. Now, how do we design? Very briefly, I am telling design details because Professor Raghuram was told me not to go into too many equations and anyway, our time, engineering students go to library, open the book, and if the equations are wrong, they will skip everything and they will read the conclusion. I do not think that also same habit is there. We never used to read the equations and at the end read the conclusion because, of course, if you have to write the exam, you have to read the equations. That's a different. Now, that's why I skipped equations here. Now, if you are at this place at particular velocity, see there are three phases. If a satellite moves from Earth, Earth's gravity will be the primarily depending attracting force. So the design has to be done according to the Earth's gravity. It's called at some place when it is traveling towards Mars. At some place, Earth and Sun's gravity pulls will become almost equal, and then it leaves Earth's sphere of influence. Then it enters the heliocentric phase where Sun's gravity is the most dominant. Afterwards, as it reaches nearer to Mars, Mars' gravity starts attracting more, and the Sun's gravity and Mars' gravity, when they become equal, it enters the Mars field of sphere of influence. Okay, roughly from Earth up to 9,13,000 kilometers, it's called Earth's sphere of influence. And afterwards, the travel of another 220 or 300 billion kilometers will be in the heliocentric or Sun's sphere of influence. Afterwards, something like 5,50,000 kilometers, when we reach nearer to Mars, we will be in the Mars sphere of influence. So these are three things. So no analytical exact equations can solve this problem. Each of them have to be done only by numerical solutions. And then they have to be exactly matched when it is crossing from one node to other, which is not a very defined point. It is a very gradual change. So this is called in aerodynamics and mission dynamics, it's called patched conics. Each of them is a conics. And now, for example, if you see here, it leaves Earth and then travels almost parallel to Earth. Earth will be moving like on this line around the Sun. Sun is somewhere here, and then it leaves a sphere of influence here, and then moves almost parallel to the Sun. And then again, when it goes there, it enters into the sphere of influence of the Mars. This is the way it travels, and roughly to reach from Earth to Mars, it may have to travel something like 400 to 500 million kilometers. That much it has to travel. Now, this velocities, as I told you, first, for moving out of Earth's gravity, roughly there has to be something like 11.5 kilometers per second. And when it moves from 11.4 kilometers per second, and it starts moving, when it is moving parallel to Earth, it will have an additional energy of something like 3 kilometers per second. Right? And then when it enters the Mars, it will be almost nearer, relative to Mars, it will be having about 6 kilometers or 5.5 kilometers per second. And there we have to break the velocity. We have to reduce the velocity by roughly 1 kilometer per second. This is how it happens. If you want to first put it in the orbit around the Earth, we have to give something like 10 kilometers per second velocity. Then it will be moving around the Earth, then you have to give an additional 1 kilometer per second extra to make it around 11.4 kilometers per second. Then it leaves the Earth's gravity and starts moving towards Mars. Then when it reaches very near to Mars, we have to reduce by something like 1 kilometer per second so that it's captured by the gravity of the Mars. This is the criticality of the design. Basically, everything has to work precisely, otherwise it will either miss the Mars or crash onto the Mars. Both are possible. Okay? And both happened. Both happened in the last 50 years of history. Now, there were 57 missions so far in the world towards Mars, starting from 1960. And 1960 to now, there are only 28 missions which are successful, because one of them is Prasad. So, roughly you can see here, 50% of the missions failed, 57 launched, and 28 only succeeded. And the very unlucky country in that respect was former USSR and Russia. Though former USSR and Russia is number one in the world for space, and number one even today in the launch vehicle technology, it miserably failed in the Mars missions because 1960 to 1970, practically all failures were USSR failures and 2-3 failures of US. And today, the most successful of the Mars missions is USA. USA had got excellent, as you see here too. But then some of the mission failures, because you are engineering students, you should know, some of the failures were very, very, I should say, engineering-wise bad, and we should learn. There is a set of chemicals, what we call hyperbolic. When they join together, they are used as the propellants in our rockets, like your fuels in your car. When they just join together, you don't need to give any combustion; they automatically combine and combustion takes place. That's called hyperbolic. That is UDMH and N2O. In one mission, one check valve. They're normally the satellite. They're stored in 2 tanks and they are fed into the engine. And at this point, we open. But the single gas tank pressurizes both with a flange stick. But because they should not mix, we put check valves. That means check valve means mechanical people will know. It will allow in one direction the gas flow, and in other direction it seals. But one of the check valves had a leakage, very small leakage. So by the time 10 months it reached Mars, it had leaked into the other line, and the moment it was opened, it exploded. Then the launch took place, and then it traveled 10 months towards Mars, and just when it is about that 1 kilometer per second, which I told velocity has to be reduced, when it was to start that operation, when they opened it, it failed. So this is one failure. Another failure was because of wrong units assumed by design team and operations team. The design team had assumed that every pulse is 1 lb second. 1 lb means roughly about half of a kg. So that means every pulse means 5 kg seconds. Okay? 5 Newton seconds. But the people who are giving the commands, they were always used to every pulse 1 Newton second. So they were going on giving pulses to reduce the velocity, and they were reducing so much it crashed onto the Mars. After reaching Mars, it crashed onto the Mars because just units assumed by the design team and operation team were different, and they were not communicated properly. Okay, and what you know, in such a mission cost for USA something like $500 to $600 million minimum. $500-600 million means roughly 3,600 crores is a mission. And such a mission, after reaching there, just before landing, such a thing happens because of the communication gap between 2 sets of engineers. Okay? That's why we call 2 things very important in space. One is units, second one is sign convention. Everybody should follow the same sign convention. Okay? Next is sign convention is not the cinema sign convention. It is your XYZ. Okay? XYZ, clockwise and anti-clockwise. Okay. Now, there is another one which failed because the engine was started and computer is given a command that computer, if it senses a shock from the shock sensor, it should stop it. Assumption is when it lands on the Mars, when the leg touches, because of that shock, that shock sensor or vibration sensor will sense that shock, and with that signal, computer has to stop. So engine started, then only legs which were folded were deployed. Because the leg deployed, this shock that sensor detected. So the computer thought it already touched the Mars and switched off the engine. So it stopped. So afterwards, the big lesson all of us have learned is that you should first deploy the legs, then start it. So that you will not have it. This is as simple as that. This is learned at a cost of, as I am telling you, 3,600 crores rupees. Okay. Now, the last one is very unfortunate. Phobos grand mission of Russia. It failed because it's a mission going to Phobos, that is the moon of the Mars. It was assumed, finally it came out that one microprocessor chip, what they have purchased from Comcast, was not radiation qualified by the government. Somebody took a bribe from the fellow who is purchasing it and gave him a non-qualified component, a commercial component, which the moment it was put into the space, it failed. Okay, and that's just a big mission. Actually, it was exactly at the time USSR collapsed, and Russian engineers had no salary, and all the Russian engineers of that mission were working on the daytime as taxi drivers and earning their life, and night they were studying and working for the Mars Phobos grand mission. And I had practically seen them trying after this mission. I mean, Russians never crack. Okay? Even if they kill 100 people, they won't. It's true of anybody. Okay? In India also. Okay? Don't think that we are great. We also kill hundreds of people and don't cry. But on the mission when it failed, I saw all engineers crying because they were working on the daytime as taxi drivers and helpers in the labs because the country crashed. But night they were working for almost 3 years, and then the mission failed. Now, these are some of the failures of that, what I told you. 29 missions failed, almost 50%, and the 28 only succeeded. But the missions which have succeeded have given excellent. This is one of the missions in 75, called Viking mission, 1975 by NASA. It has landed on Mars in March 76. And then it worked up to 1980, just 4 years it worked, and it has provided excellent 50,000 pictures of Mars. And this is the first set of pictures Earth had about Mars in detail, and also it detected so many things. It detected carbon, because normally you know the Mars in the night time looks very red. Okay, if any of you are interested in seeing in the night flash. That's because ferrous elements. But it detected nitrogen, it detected carbon, it detected tungsten. So many elements it detected, and this mission is one of the best missions in the very, very early phase. Okay. Then in 96, 97, NASA launched a mission called Mars Pathfinder. Its entry mass was 566 kg and lander mass was 325 kg. It's a very big mission. But at that time, they didn't have exact, precise soft landing technology. So what they did, they put it in a big air bag filled with air, but the configuration is such a way that whichever way it tumbles, finally it will come into the west in the position where the satellite is operating, so that it will work. So they just, it is something like a putting your satellite in a big football and then throwing it. And then it bumped 3-4 times and stopped and then deflated, and then the lander came out, rover came out. This is the rover which has come out and then did a lot of work, and this was first time the rover was only 11.5 kg. I am showing this is the first rover on Mars which was put by NASA was just 11.5 kg with a payload of 4.5 kg. Now you will see what they have achieved. Now, after this, in 2000, there are two satellites launched. They are called Spirit and Opportunity. They are called Mars exploration rovers. Both of them are rovers. They just went into Mars orbit and then came out of the Mars orbit, deorbited and soft landed. And they were communicating to NASA through European satellite orbiters. Okay? And each of them are 180 kgs of rovers. And the Spirit drove on Mars 7.7 kilometers. But the other one, Opportunity, today it's a record. Opportunity drove 45.16 kilometers. 45.16 kilometers over a period of 16 years. Okay, it's not very fast, okay, as we know. But 45 kilometers it drove, and that is the record as of today. And it has given, they have given excellent things, and they have demonstrated the navigation technologies and rover movement technologies where if a rock comes on the way, they can avoid it and travel. And if the slope, they will assess whether it can move. And if it is below some angle, it will move and cross over even these slopes, either up or down. Okay. Now, this you see, just it looks like as if we are seeing either any place where there is a big desert on the Earth. So this is Mars Express of European Space Agency, and it's like a Grand Canyon. It's called Grand Canyon of Mars. And this has given this picture is 1700 kilometer and 65 kilometers. It's a very good picture, and this type of pictures are used finally for where to exactly land for the further things. Now, this is one of the best missions of NASA. It's called MYS. It was launched in 2007. As I told, you will see all opportunities once in 2 years. Okay, if there is something was launched in 2007, again next one will be 2009, or next one will be 2011. So this was launched in August 2011, and at Mars at the launch time was 195 million kilometers, and then its object was only 90 days of work, and it has got spacecraft mass at launch was 664, and the lander mass is 410 kg. Now already we have reached 410 kg lander mass, starting from the first rover, which was successful, which was only 11 kg. And it has got 59 kg of science payload, and it has got fan-shaped solar arrays, which generate the power. And actually what happens was, when a lot of dust storms come, the dust settles on the solar cells, and then the power will fall and it will not be able to use. This is the general thing, but this worked very well for a long time, and it has got the robotic arm which can dig and take out the soil and test it on the spot. That is, it has taken a chemistry laboratory to the Mars, and it can scoop a soil and move it and put it in a oven, heat it and cool it, or whatever you want to do, what you are doing in chemical lab it can do. But before that it can calibrate. It has taken samples from the Earth. First it will put it in that and test it whether the oven or equipment is properly working or not, and then it gets the data. Now you will see one of the important of course this is how it happens. What I was telling is the first hyperbola, then Hoffman ellipse, then hyperbola. This is hyperbola of Earth based, and this is the interplanetary travel, which is elliptical travel, and this is again hyperbolic approach. That's why it's called Patrick Collins. Now, when this was launched, the satellite when it was launched, see, you see the launch here, and then after launch there will be one correction will be done, then there will be another correction will be done when it is going, and goes finally here, and it will arrive, and when it arrives, the Earth is already here. That is, the Earth with the launch time it was here, it already moves here, and the Mars, which would have been here, would have moved here, and then it comes here. Then actually what you see, what they do is two things there are rules. That is, we should not take any biological loads onto the Mars. So they have to be thoroughly cooked on the ground. They have to be for days together. We have to put it at roughly 300 to 400 degrees centigrade and see that all microbes die before it takes off. That is one. Second thing is, if there is any stage or chemical stage which is pushing the satellite, it has to be designed in such a way that after it does the final operation here, when it is separated, it is put on a trajectory such that it will miss Mars and goes. Mars comes here, satellite goes and gets into Mars orbit, but the final stage which gives the final velocity push will be separated and directed in such a way that it will go and miss Mars and goes into the deep space. That is how the mission has to be designed, because you should not go and contaminate Mars. That is the international agreement. Now, this is how normally these things are assembled. This will be, this total thing, in the case of Phoenix, this is the total thing. This will be the orbiter. Together, they will be together when it is in the Mars orbit. Then this portion will be separated. This portion will be separated. Then this is the heat shield and starts coming down. And at the time, this heat shield will be removed. And then the deorbiting firing will be done. And after some time, this portion, which is called back shell, will have. This back shell will have, in the latter cases, they started putting parachutes, but back shell will be removed. This is also mainly as an interface to the satellite. Then this portion of it lands. That is how it is designed. Now, the landing sequence is done like this. Initially, it will be in orbit around the Mars. Then there will be, the stage will be separated. Then there will be, the heat shield will be rejected at some altitude around 45 kilometers. Then the parachutes will be deployed. And the parachutes slowly bring it down. And when it brings down, and when it comes to certain level, the parachutes will be disconnected, and it comes down and lands. Of course, while landing, you have to fire, because the gravity will be pulling. If you don't fire the engines in the other way, it will come in and will crash. Without crashing, it will come in a very slow manner. And then finally, after it lands there, there will be a lot of dust up and there will be a lot of dust rising. So for the dust to settle, about 3 to 4 hours, nothing will be done. After that, solar panels will be deployed. Then it will start running. Now, the robotic arm and a camera on the robotic arm, and then the thermal and evolved gas analyzer, microscopy, electrochemistry, and conductivity analyzer, and meteorological station and laser. Okay. Meteorological station is nothing. Actually, there is how much is the wind velocity is there. So there will be a small flag-like thing, and its movement will be detected, and that will be the measure how it will be, like that. Then this, if you see here, practically they have taken a chemical lab to the Mars to test the Mars soil and Mars gases samples. This is the most important thing. Otherwise, it's not possible. But future, what they are going to do, I will tell you, in 2020, they are going to collect some special rocks on Mars and store them. And a future mission will bring them, because the chemistry lab, which has to test whether there was life some 2 to 3 billion years back on Mars, requires this much size of labs. Cannot be taken. So rocks they are going to bring soon in the future. Now, this is how it is. Each of the labs, you can see the positioning. The Mecca is here, and meteorological station is this, and thermal and evolved gas samples were this. And all of them have taken number of samples with them to calibrate the equipment on the spot. And this is the robotic camera and robotic arm. Now, this is one of the pictures. You can see it is as good as most of our villages long back used to be like this. When we go to the fields where there are no plants or anything, it used to be like this. This is how they do this. Now, This has got an excellent investigation done and excellent invention, I will say. You see two pictures. First one is on floor 20, that is 20th day, and second one is the 24th day. And 20th day, when the robotic arm scooped the Mars soil, it suddenly there were some white patches were seen in the picture. So these white patches, this was somewhere around I think 2003 or so. Okay. Now these white patches immediately gave a doubt. It could be three things. It could be salt, it could be carbon dioxide ice, or it could be water ice. So to find out, they wanted to wait, because if it is salt, there will be no change in this. Even after a few days when you take picture will be as it is. If it is carbon dioxide ice, it will evaporate very quickly, within 1 or 2 days. If it is water ice, it will slowly evaporate at that temperature. So they waited 4 days. You can see here, from this picture to this picture, you can see slowly this light has gone. And on that day, Smith declared that we have found water ice on Mars. This was a great invention, great identification. There was water ice just below the surface of the Mars soil. Just a small amount. Afterwards, when they turned the camera and looked there, the engines which fired for it to land has removed a lot of soil and it was full of ice. Afterwards, they have taken pictures and found that there was a lot of ice there. Okay? And then what they did was, this ice portion of the soil they removed, and ice portion they have taken and put it on the chemical lab. They heated it, and the steam generation they have identified. Before that, they put the water sample taken from the earth and detected the steam generation, equipment is properly working, and then identified that the soil is also heated and there was steam, and then the water ice on Mars was confirmed. This was this was 2008. Okay, 2008. This was detected. We were at Hassan at that time. Okay, you can write. And we were close touch with all of them, because normally all the satellite operators all over the world will be in touch with each other for some problem or other, or some emergency which comes up, will be consulting each other. So in fact, I heard Peter Smith talking about this water ice, they found it, and we were one from India who congratulated. Now, next came Mars Science Laboratory. So Curiosity is called, popular name. It was launched in November 2011 and landed on Mars in 2012. And mission duration of 687 days. It's still working. Latest is on November 9th. Today is 6th. Okay, on October 9th, they have taken a picture of Curiosity, a picture, and they sent it down. And there are 4 objectives. One is to investigate habitability study, and to study nature of organic carbon compounds, and to study cycling of water and CO2. And it traveled this also. This rover has traveled 21.2 kilometers. And this one is slightly different in the sense it has got the earlier rover, what you have seen, has got the solar panels opening out and generating power. And this has not this has got the nuclear power. It's called nuclear power generation. Plutonium they take, and by the natural decomposition of the radiation, they generate the power, and it's called radio RTG, we call it. That is radio thermal power generation. Okay, radio thermal power generation, and this, because the advantage of this is, even if there is a lot of dust storms, or even if there is a night time in the Mars, it will still generate the power and we can continuously operate it. That's why it's working so many years now. Okay, but landing sequence is almost there. That is the separation, removal of the back shell, heat shield, then opening of the parachutes, then changing the direction, then removal, separation of the parachutes, firing the engines, and then landing is soft landing. this portion is common, and whereas this portion, our generation is exclusively separate for the curiosity. Now, ISRO, Mars Orbiter Mission, we took up 2013 November. I was the director of Sri Harikota Center at the time, and I was also chairman of the Launch Authorization Board, which takes care of mission, network, international contracts, international readiness, our readiness. All aspects will be under the control of chairman of the Launch Authorization Board. And we launched it in 2013 5th November. It so happened that 10 months travel, it has to be on 2014 September, it has to reach Mars. So we had to do it in November. And October, normally October 15th to November 25th, we don't do any launches from Shah because of the cyclone. So we had to do exactly during the cyclone period. And the problem in cyclone period is when we take the launch vehicle to the launch pad and we start building the launch vehicle, if because of cyclone any part comes off and hits it, it will put off our launch by more than 6 to 8 months because we have to disassemble the whole thing and replace so many things. So we had to do lots of strengthening of the systems, not the launch vehicle, nearby handling systems. And finally we launched it. And of course it was launched with PSLV. So because of that, we can only launch 1337 kg. That is the lift-off mass of satellite is 1337 kg. And it has got propellant of 855 and dry mass of 480. Dry mass means the satellite mass. Okay? Satellite dry mass plus some small part of the propellant will be there when it goes into the orbit. It has got, it is initially put into an orbit of 250 km by 23,000 km. Nobody has done this type of operation because they have very powerful launch vehicles. US has got very powerful launch vehicles. So they can straight away launch and maybe in one orbit they will start traveling towards Mars. But we had to do a number of operations, you will see here. And we had 2-3 challenges. Number one was we had only reliable launch vehicle PSLV. And PSLV can only put 1600 kg into remote sensing orbit of polar orbit, or in a 230 by 36,000 km orbit, it can only put 1000 kg. So 1337 we have taken, and we have taken a sub-GTO. It's called sub-GTO, 250 km per EG and upwards of 24,000 km. And in sub-GTO, after that, for the fourth stage, we had to give a long gap before firing force. And when fourth stage fires, fourth stage will be firing over New Zealand. And over New Zealand, we do not have any station in the sea. So we had to send 2 ships. We hired 2 ships from Shipping Corporation of India and sent them towards that. And for there, the launch vehicle will reach from the takeoff up to this point in about 10 minutes. But those 2 ships will take 2.5 months. So they started some 3 months back, and one generator caught fire and ship stopped on the way. And another ship, we have put a satellite tracking antenna, that antenna was not moving. So the 2 ships were stranded at 2 places. So quickly we asked them to move to some places, and then we took a decision that okay, we launch. We will take a blind faith that our fourth stage will work. No need, because these ships have to go and they have to see fourth stage is performing. Fourth stage fires, no problem. If it doesn't fire, at least we should know it does not fire. Only for that ships we are sent. And to get the data why it does not fire. So I took a decision, okay, the third ships will go up. Then 2 days or 3 days before the launch, urgently they called me and told we solved the problem, so we go up. But okay, you go. You travel as fast as possible. If you reach the spot, you track, otherwise we have already forgotten you. So they reached the place and they tracked. They reached the place an hour before the launch and they tracked that PS4 excellently worked and then it put into orbit. That's the first phase. Afterwards, we had to increase the velocity here because when we put it in that type of orbit, the velocity here will be about 9 kilometers per second. In this orbit, the velocity of the satellite here will be 9 kilometers per second. But we have to increase it to 11.7 kilometers per second to travel on this path. So every time it comes here, we have to fire the satellite engines to keep on increasing the velocity. When we increase the velocity here, this apogee moves further and further. So this is how. Actually, in the case of moon mission, we do it such a way that this point reaches moon station. But in the case of Mars, we went on increasing the velocity. Finally, when it is 11.7 kilometers per second, it travels on this path towards Mars, and then it landed on, it reached Mars on September 20. Then the problem was, the Mars reached in this place slightly ahead, and the satellite has to go behind it and then capture. And when it goes here, it has to fire its engines and reduce the velocity by 1 kilometer per second, which was not visible from the Earth. So we are not getting the data. So we loaded 2 days before what the engine has to do, and we were 12 minutes. We were watching 12 minutes. There is no communication. So we do not know if it fires, it will be in Mars orbit. If it doesn't fire, it will go. Okay. So we wanted to know. After 12 minutes, suddenly we knew that it's in Mars orbit. Okay. These are the things which happen in engineering. So you have to be prepared for that. Okay. Then it has got 4 payloads, and even now also it is taking some color pictures of Mars, and then our then Seven has nothing else to talk. He will say Mars mission. There is one more picture to be seen. Okay, some of you can see that. Okay. Now, what USA and ESA are going to do? Because the Indian Mars mission is only a small mission compared to all these missions to show our design and technological capabilities that we can design the mission and reach Mars. It's a technology demonstration. But don't see the Indian TV channels, okay, and Indian newspapers. They start talking because by night 9 o'clock, all these super patriots and the TV channels get fever and start becoming super patriotic and start talking. We are better than NASA, we are better than NASA, we will teach them and all those things. Don't believe that. Don't believe that. I think it's true. I'm telling you, I think there is one Hindi movie with Akshay Kumar, which it's an idiotic film. I saw it says somebody in Uttar Pradesh who says how to take out the puri from the pan will go and tell NASA people how to switch off the engine for the Mars. Okay, I think I had not heard such a more idiotic thing than that. Okay, don't believe. That's why I'm telling you, these are all people watching. The engineers, you are professionals. You should know thoroughly what we are and where we are. We should be proud of ourselves, but we should not be. Okay. Right now, NASA has planned an opportunity and curiosity. Opportunity and spirit, which are about 400 kg, and then it put the curiosity, and then this is all over in 2016. Then it has planned in 2016 a mission called InSight. InSight is a mission where it puts a lander onto the Mars, and it has got 2 excellent packages. One is to measure the Mars quakes on the Mars surface to the level of 1 atom movement. Okay, 1 atom level movement is the precision of the measurement, and that is made by French Space Agency. The package is made by French Space Agency, and there is another mission, another package which is called which will dig into the Mars surface 5 meters deep and measures the heat flows, temperatures at different places, so that it will see how the heat is generated. That information will prove to us whether there was any life, 2 or 3 billion years back on Mars. So that we will know in future whether all your grandsons will live or won't live. Okay, that is the type of thing information. And the second package is done by German Space Agency. So German Space Agency had done a package to measure the heat subsurface up to 5 meters, and this French Space Agency had made a package which moves the Mars surface movements to the atom level, and that has to go on the rover based on actually the Phoenix. Earlier I told you Phoenix with two fan-shaped solar cells. The similar type of thing are inside they made it, and this is made by NASA and is carrying these two packages, and it was supposed to be launched in 2016. What happened was, because this seismic parameter, seismic package should have absolute vacuum, and that vacuum pump had a leakage of they couldn't detect for more than a year where it was leaking. So the mission was postponed. Obviously, when 2016 mission postponed, it can go only 28 after 2 years. So because of 2 years, the cost increase for them was $200 million. That is about 1,400 crores. 200 into 70. 14,000. Sorry, 200 million into 7. Okay, 1,400 crores they had to spend because it is postponed. And in 2018 it is launched. And now Europe and Russia together again launched something called ESA's Roscosmos. It is Roscosmos of Russia and ESA put together. It's called ExoMars. They plan 2 missions. One is in 2016, other one is 2020. The 2016 mission went there, and lander entry into Mars atmosphere started in 19th October 2016. It reached up to 3.7 kilometers, and just at 3.7 kilometers, the engine failed and it crash landed onto Mars. Okay. So something like Chandrayaan 2 in the flashback on Mars. Okay, that's what happened. And the ExoMars 2020 will be planned, and 2020 will be launched. And unfortunately, it's again Russia. It tried its best to get out of that failure what it had on Mars mission. Otherwise, Russia is one of the top in the space. Even today, Russia is the #1 country in the world for the space. Now, the NASA InSight, it has got, actually its name is Interior Exploration using Seismic Investigations, Geodesy and Heat Transfer. That's why it's called InSight. And it has got 2 packages, Seismic Experiment by CNES France and HP3, Heat Flow and Physical Properties package by German Space Agency. Now what happened was, actually this HP3 was this year, February 19th it was deployed. And it will have this again. This arm will take it. Actually, for all these things, that remote arm has to work properly, because that has to take the package of the seismic thing and put it on the surface. It has to take the other one which has to dig in. This HP3 is supposed to go 5 meters inside, and it's called self-hammering nail. So it keeps on digging inside, and then it has to go inside. And it pulls with it a tethered cable, and that cable will have heat sensors every 10 centimeters temperatures. With that data, heat flux will be calculated. So it was the 19th February of this year they started deploying. After 9th March it went about 30 centimeters. Afterwards it's not digging. It's not going. Now they were trying from March to now October. Latest in October, what they found was the soil. The idea is actually if you dig up to 5 meters and 50 sensors of heat data you get it, you will know heat flux calculations, and you will find out whether there was any remaining temperature on the Mars planet as a after all heat was taken away by the solar winds, whether something is remaining. But 30 centimeters only it has gone, and it's digging, but it's not going in, it's not digging. So finally what they found out was the soil of Mars is not having sufficient friction for digging. This is what the JPL conclusion. Because for digging you need friction, it seems. Okay, civil people will know better than us. So what they are trying to do now is, they are trying to, with the remote arm, they are trying to push this to one edge of the hole, what they have drilled, so that it will still dig, but it's not, it's coming out. Okay, so 30 centimeters only. So this is one of the costly things, and hope that they will make it all right. But still they are trying. Okay, and here lander mass is 360. Now this is the type of thing. As I told you, there are two fan-shaped solar arrays. This is the one interesting thing is this inside creates something like 4 kilowatts of power on Mars surface. Mars surface, the sun's illumination is very small, so it is very difficult to generate power. But this generates about 4.6 kilowatts. And these are the various instruments. This is the instrument which should go up to 5 meters. 5 meters means what? It's about 10 feet, maybe 12 feet, okay, 15 feet. Okay, this much depth it has to go onto the Mars surface, but now it has gone only 30 centimeters up to here. And then this is already deployed and it's measuring. I mean, so far no result has come. Okay. Now, on 2020, they are going to have a big mission called Mars 2020 rover. It has got 4 objectives, and its plan is it has to travel 5 to 20 kilometers. It has got 4 objectives, all about human beings surviving on Mars. First thing is whether there was any life some billions of years back on Mars in microbial form. First, identification. Second is to look for any of the signs. Third one is how do they find out? Because they have to go to some special types of rocks which have got special property to retain a life carrying microbes inside for billions of years. There are some special rocks like that. They have to detect the rocks, and an instrument has to go, it has to drill there and find out whether there is any microbial life. And second objective is to collect some type of rocks there. Third objective is to store them properly there itself for a future mission for people to go and bring it back, or a future system to go and bring it back. And last one is identify subsurface water and generate oxygen from carbon dioxide. Because as I told you, Mars atmosphere is full of carbon dioxide. There is no oxygen, there is small. So people cannot survive. People have to survive. You have to generate oxygen from carbon dioxide. That means you have to split carbon dioxide to get oxygen. So these are the objectives, and it's a 6-wheel, big rover with a nuclear powered power source, which will travel at least 25 kilometers. That is the minimum objective. But today's record is 45 kilometers. So they may go even higher, and then it will have all other types of things like spectroscopy and gas spectroscopy, and then digging it, taking samples, keeping the rocks, special rocks in a special enclosure. All those things will be there. And then this is how these things are there. And this is an interesting experiment called OXY. That is, and how it will be delivered is, this is called sky crane maneuver. Because in future, NASA has identified in future, people have to go, this type of small 400 kg rovers, landing them there is very difficult. So almost half the size of this room may have to be taken and put it on the Mars. So it's not possible to do this type of thing. So what they are planning is to carry this as a part of the satellite, and then when the satellite fires the engines and comes down, this crane will lower it. And the moment this touches the Mars surface, these cables will be cut and this satellite will fly. This is called sky crane maneuver. They are going to land it as sky crane maneuver. If this is successful, then even big ones, because they can launch even tons to the Mars orbit. Right now India cannot do, but NASA can do even tons. Some 8 to 9 tons it can launch up to the Mars. So in that it can be 2 or 3 tons can be with the human beings. They can land it using this. Okay. And then this is the experiment. This will be interesting. It's called MOXY. What they want to do is carbon dioxide, you take it, split it, and get oxygen. and again a part of the oxygen combine it with carbon and make it carbon monoxide and release it into the atmosphere. That's how oxygen they want to make it. But that process is very, very difficult because you have to do this splitting at 800 degrees centigrade. It's a very costly and also very heat intensive. 800 degrees centigrade you have to heat, which you need power. And that power has to come again from the solar panels or whatever nuclear power sources. So this is the one, and this got a lot of money they are pumping into the research. Any of you also can start doing this with your chemistry background. If you want to start doing this everywhere where I am giving talk, I am giving them this as a challenge. Carbon dioxide in an affordable way with a low temperature, you try to split it and get oxygen from that, you will be flown next day by NASA back to them. Okay? Right? So this one is going to be 2020. That is next opportunity. 2018 was the last opportunity. InSight was landed. 2020 is next opportunity. That is 2020 August. 2020 August this will be launched. Okay? Now, after that, what happens we still do not know. All the space agencies are trying to know their best to know how to survive. First find out whether there was any life form on Mars billions of years back. If it was there, how did it lose it? Third one is, how did Mars lose its atmosphere? Fourth one is, are there any human sustaining elements on the Mars like water and the carbon and the organisms, okay? Organic compounds. Then next is how to generate oxygen and real-time resources, in situ resources for science. So these are the overall objectives, and it may take 50 years or 100 years to see this. Meanwhile, the technologies we are developing on the nuclear power side, where the travel time can be reduced from 9 months, 10 months to 2 months or 3 months, so that we can quickly travel and come back. But once you go there, you can't come back for 2 years. So anybody wants to go, be prepared for 2 years. That's all. Thank you very much. It is done. Mostly what is done is the similar type of land is created, and then it is driven, and a lot of experiments will be done. First of all, the fundamental thing is diameter of the wheel. What should be the diameter of the wheel? That is the most important thing which we have to finalize based on the stability. Second thing is mass, because every gram matters. For every gram, crores of rupees you have to spend. So we will try to reduce the mass as much as possible so that it is very lightweight. At the same time, it should not tumble. So these are the two parameters. Based on that, it will be designed. Then it will be driven everywhere. All worst places it will be driven on the ground to see that it works. And finally, actually, I am told, okay, don't quote me, I am told, even these things, whatever you drop, whatever you put with parachute and other things, all that we do on the ground also. Even when something we have to recover, we do it. So the Chandrayaan 2, it was supposed to be released from a helicopter, and the engines are supposed to be fired and it is supposed to be landed smoothly on the ground. That test alone is waived because there was some problem. And that's where it gave the problem on the moon mission. Okay. So we do. For example, if we SRE, that is satellite recovery experiment, we take it on a helicopter, drop it, and then release all the parachutes and all the things, and then all the ships and the people collecting, bringing it back, everything. All this we simulated as much as possible. We miss 1 in 1,000. That 1 in 1,000 will definitely happen in the These are my experience.
Yeah. You said that that there was a failure when there was a leakage in the wall. Check wall. Yes.
Right.
It happened after reaching nearly reaching the Mars. So how do the engineers on the Earth know? How do the engineers on the Earth know about that failure?
What engineers knew is when they opened the gas wall, it exploded. That's what only they knew. So they went back after the records of each of the things. Then they found the wall which they used on one side of it had a very minor leak in one of the tests of the ground, which they have waived. Because any ground test will not be 100% perfect. We all sit together and see each parameter, okay, this can go. We can go ahead with it. Like that, we waive off some deviations, go ahead. But unfortunately, that's okay for a Earth orbits in Saturn. Because time is only a few days. Because it's months together, the small leakage had sufficiently added the other gas into this one.
SpaceX recently announced
Sorry.
SpaceX he recently announced that he's going to land a 200-ton orbital class rocket on Mars propulsively by 2020. Do you think it's possible?
Possible as long as US government gives him money. Elon Musk or Mukesh Ambani will not spend a single rupee of their money. They will take either from US government or Indian government and spend. Incidentally, all of you must know Mukesh Ambani is one of the top richest man in the country, correct? And his net loan means his loan minus value of his assets is equal to 1.5 lakh crores. That means he has become very rich man on paper by taking more than 8 to 9 lakh crores of loan from the banks and institutions of India. That Elon Musk doesn't like that. So he can launch. Technology is possible. If you have powerful rocket, you can do.
So on Mars atmosphere, there is plenty of carbon dioxide present. So oxygen will escape because of low gravity, and because of that, carbon dioxide only remain. Or we produce oxygen there.
I do not know. NASA people also do not know. They knew only one thing. Some theory was there was an atmosphere like on Earth, and the whole Mars lost its whole atmosphere because of the heavy solar winds. Because there is no strong magnetic field like the Earth, which is protecting us from the solar winds. There was no such strong magnetic field around Mars to protect it. That's why it is lost. This is one thing. Immediately somebody asked, then why not carbon dioxide also go? Why is it remaining there? We do not know. Okay, methane is one. One possibility is being methane there. It's continuously being produced. That's also possible. So right now we do not know how that atmosphere is still 95% carbon dioxide. Is it losing every day and being created, or it is static there? These are all the things which we have to study. If they have to study, and we have to read from their topic. Sorry? Yeah. Yes. Yes. Sorry? Yeah, there will be delay. There will be some amount of minutes of delay. Suppose something happens on Mars to Earth, something like 12.5 minutes or something it takes for the data to reach. So whatever data you see is something which happened 15 minutes back, sent back. So you get the data. Even now, for example, if you see some star which is glowing, it was some light years back. It was there. It is not there right now. So like that there will be delay. Okay, but we have communication. All these landers communicate with the orbiters which are going around the Mars, and those orbiters will send the data to the Earth. Deep Space Network, which is having stations at Madrid and Australia and US, and one at Bairalu near Bangalore. So all these things will be receiving the data and sending. Yes. X band and S band. Also. Yeah.
You said that one of the objectives of future Mars mission is to search for survival of human, survivability of human life. So why are we so, why are we thinking like that we have to leave the earth and maybe we might have to leave the earth in the future and live down and rather than spending our resources in the earth.
Whether we like or not, sometime in future we have to leave. We call Tsiolkovsky, a physics teacher of Russia, as the father of rockets. He told long back, there's no rocket. He is the man who had invented rocket equation. He is the man who had told these are the fuels which you have to use. He told this is the way you have to design rocket. Long back. He is a physics teacher. He told at one time, the earth is like a cradle for human beings, like babies. But you can't be a baby all through your life. Sometimes you have to go out of your cradle and start walking. So earth is like a cradle for us. We are all still babies on the earth, on the cradle. But sometime in the future, after maybe 10 generations, we have to start walking in the space. We do not know what will happen to the earth still. Okay? So we have to find an alternate place. At least we now know that in the history of the planet Earth, there are many species which are completely extinct because either they could not adjust to the changes or they had come across certain accidents. Tomorrow an asteroid can come and collide with Earth. Not tomorrow. Okay, sometime it can come and hit. Okay? So tomorrow I am going back to Guntur. Definitely not tomorrow. Afterwards it can hit the earth. Okay. Now it can hit the earth. Okay. So many things can happen. That's what I told. We are blissfully ignorant. We are thinking, we are quiet, we are calm, we are sitting, but we are revolving, we are traveling at a very high speed, and we are moving because the whole space is even and without having any much differences, and the whole thing is good. We are surviving. A hole and the magnetic field is sufficient for the whole earth, and 0.0001% increase of the sun's energy towards earth. Everything will be burned in seconds. Okay? So we have to find a place to live in the future.
Mars doesn't have its own atmosphere mostly. It has
Yeah, it has an atmosphere, not like
81% of Earth, that is what I heard, and it doesn't have any magnetic field of its own. That means the Earth radiation sun's radiation is going to attacking it every time, and there will be huge winds. And also the pressure on the Mars is very less, that I see. And if I stand on Mars, my fluid inside my body is going to boil because of the low pressure. So the fluid inside our body is going to boil, and there's a radiation problem. And all these problems are there. So, and why only Mars? And are we going to terraform the Mars? Terraform the Mars?
all other places are worse than Mars. Try to go towards Mercury or Venus, halfway through itself you will become carbon. If you go that side, you have a chance of surviving.
But if we want to terraform the Mars, how are we going to confine the gases in that atmosphere?
I will. First thing is, the four inner planets, the Mercury, Venus, Earth and Mars are solid. In the sense there is some crust, there is some stones, there is some rock and something solid. Beyond that, if you see Jupiter, Neptune, Pluto and all these things, and Saturn, all are gaseous planets. You can't even, if you go there, you don't know where you will see. Okay? So, that is one part. Second part is, any manned mission, the weakest part is the man or woman, human being. Okay? So, we will just like that put a person and throw him onto the Mars. There will be suit, even though outside there is no pressure, there will be proper pressure will be maintained there, proper humidity will be maintained, oxygen will be given, That's why you will find all these people who are walking on the moon and who are walking in the space from space station wearing all that suit. That suit will maintain everything, so that the human beings will not just like that die.
So why can't we do that first on moon and then we could such
Moon already done. Moon already done. Moon also they are going to do.
like we can terraform it and just settle there, do some colonies there, and develop that thing in the moon and then go to the Mars.
Yeah, that is the you are very close to Trump. That is the Trump. That is the idea of Trump and Obama. What they are doing is they first want to go to see. Their direct Mars missions are now cancelled in weeks. Manned missions. So they want to travel from moon only to Mars. So first they want to settle on the moon. And for that the Germans are trying to say moon village or European Space Agency people. And Americans wants to construct a museum where they first landed on the moon, Apollo 11. And we are all objecting, telling that it's not your country because there is a law in the world saying that outer space cannot be owned by anybody, whomever he likes. Okay, so you can't construct a museum and say it is US museum. There are all law, technology, politics, development, everything mixed up. Like our Akshay Kumar's. Yes.
Why can't we take microbes and all those things to Mars? Is it contaminating the environment, or is it where if we take there, we are not able to, we won't be able to see whether the life already existed because there are few microbes which we, is the reason?
I will tell two jokes. When Chandrayaan one time I was in charge at Sri Harikota as range operations director for everything. All the operations which take place at Shah. So it was heavily raining and the rocket is on the launch pad. Almost 20 days there was every day thorough rain. So we were one day happily laughing. And Prasad Nair came. He was the chairman of this ISRO at that time. He came and asked me, Prasad, why are you laughing? So I told him, no, Prasad Nair is fully drenched. So your satellite will definitely drop some drops of water from the surface, and you will say you declared you have identified water from the surface. Because if you take microbes, some other mission may find out that these microbes are living on the that is one. So, because of that, what happened professionally, all scientists of the world came together. There is a called COSPAR, Planetary Protection Guidelines. We have all of us signed Planetary Protection Guidelines. We will protect outer planets wherever we travel from the colony. We will not put any mass killing, mass destruction arms. We will not put any weapons there. We will not put any gases there which are hazardous for the life forms. All that we have put it, including, it's called actually, right? It's called biological weightage or something. There is a term for that. We should not exceed certain number, which means you should bake everything roughly at 400 degrees centigrade, about 96 hours on the ground. Then only all these microbes will die.
The presence of a third party or a third body which has to be anticipated in this 11 months window, which would affect the general travel from Earth to Mars. In all these countries,
No. Again, this also looks like some Hindi cinema only to me. Nothing happened like that. What normally we do is, there are 200 asteroids which are identified as Earth-threatening objects. That means objects which travel very near to the Earth, in addition to our own satellites. So we take all of them, their trajectories into calculation while we are going. But if something comes very near and puts its gravitational effects, we cannot find out before. But we can, all those trajectories are well defined so that we can calculate. Nothing comes surprising. Nothing will come from the blue. will come with full mathematically known equations. Yeah.
Does India today have the capability, or are we still collaborating foreign countries?
In launch vehicle, we have about 98% self-government. Okay. The 2% is some of the very complex electronic ICs we have. Because it's making them with no meaning, like A to D devices, microprocessor. Microprocessor also now we manufacture, some other thing. But many electronic components, complex electronic components we purchase. That is the 5%. On satellite side, we have 60% self-sufficient, 40% we buy from them. Okay, and okay, the experiments ours are very modest. Okay, when we launched the Mars orbiter mission at a very low cost, okay, and our Prime Minister was making all sorts of announcements saying that this is lesser than auto cost and all such nonsense. Somebody in US was asked on a BBC interview, why is the mission cost so low for India? And that man told, sir, the mission cost is so low because their salaries are very low. And I was laughing because he doesn't know our salaries we don't account at all in the budget. Okay. First of all, our salaries are low. Even that we don't account. They account everything. That's why they figure people very big. Okay. So mostly we are self-sufficient, and I think we can, unless we want to do, suppose if we want to do latest, that atom level movements of the Mars, if we want to detect or we want to make an equipment, we do not have it. That level of pressure we want.
Last,
Yeah.
what is the highest cost in terms of the whole mission? Which one is the highest budget?
So far, in the world,
No, in our mission, I'm talking about the mission for
ISRO, in India, ISRO. ISRO doing peanuts, basically. That is, ISRO started 1963, basic infrastructure. But as ISRO and Department of Space started in 1971. 1971 to 1995, 96, 25 years put together, we spent only 700 crores. 25 years. Whereas during these 25 years, USA was spending every year $19 billion. That means 19,000 into 4, something like 18,000 crores they were spending every year. And we spent over 25 years 700 crores. Today we reached something like, a big amount of money. I should say something like maybe 7,000 crores, 7,000 or 10,000 crores annually. Okay, that started from 2005 onwards. It started increasing. Our annual budget is around 8 to 9,000 crores now, not 10,000 crores at the max. But US is spending, Russia is spending, and China was spending every year 60 to 70,000 crores for the last 4-5 decades. That speaks for their results and our results.